Yes, conditions were a little rough this past weekend.
Good morning, this is Ron Finch from Birmingham in England. It's about 8 minutes past 12, Zulu, Saturday the 8th of February. A reception of your programme on 5955 this morning is virtually useless. I suppose we can blame the sun for it. It's diabolical.
Not diabolical, but geophysical, one of the many reception complaints that came in this week. Last time, as you may recall, we mentioned that a solar flare took place at 6:25 UTC on Thursday the 6th. But this flare was just slightly west of the sun's central meridian, and in oversimplified terms, you can think of this particular flare as being pointed straight at us. This flare gave out a shock wave, followed by a whole stream of solar-charged particles, which all came hurtling towards Earth. At about 0300 last Friday, as we predicted, those solar particles started to interact with the Earth's geomagnetic field. The condition of this field is given by a scale called the A-index, and we normally say that if the number is above 15, shortwave reception will be disturbed. You notice more flutter and fading on the signals. On Friday, though, the A-index was 57, and if that wasn't bad enough, on Saturday it went up to 298, with the result that in the course of Saturday, shortwave signals in most parts of the world just faded away. The last time we had what scientists term a truly enormous storm of this magnitude was in November 1960, when the index rose to 280. On Sunday, things got a bit better, moving back to 74, although still disturbed, after which things have gone quiet again. Right, let's move to propagation news now with Mike Bird on the line from Melbourne. And Mike, is there any way of predicting these solar flares and the disastrous consequences?
It's very difficult, Jonathan, to predict solar flares and fade-outs. All I can say is that they're more likely to happen around the sunspot maximum period, so what we've experienced in the last couple of weeks is really out of character. Solar observatories around the world look at the sun daily, and if a sunspot region suddenly grows in size or starts to look what they call magnetically complex, a warning is issued as to the likelihood of an event taking place. Now, if a solar flare does occur, the likelihood of a shortwave fade-out is dependent on how much X-ray illumination is given off by the flare. The X-rays are the important part.
And when you see a solar flare on the sun, how quickly does that affect the ionosphere?
Virtually instantaneously. If there's enough X-ray illumination there, it'll happen. Of course, the image you're seeing is 8 minutes old because the image takes 8 minutes to arrive from the sun.
Now, at the start of the program, we mentioned something about the geomagnetic field that built up over the weekend. Can you give us some more details?
Well, the two sunspot regions which provided us with the solar flares and shortwave fade-outs last week continued on their merry way. At 09 hours UTC, again on Thursday the 6th, fast protons, which had been ejected from the flare, produced a polar cap absorption event. And this causes a complete blackout on radio circuits traveling through or near the polar regions. Shortwave broadcasting at the height of the storm was virtually inaudible, but there was some consolation for those who could see the magnificent auroral displays in the night skies close to the polar regions. On Monday the 10th and Tuesday the 11th, the field quietened down, but became disturbed again yesterday, Wednesday the 12th, and is thought to be due to a residual effect from the storm earlier in the week. Because of all this activity, the solar flux continued to be high. Flux levels ranged between 102 on Thursday the 6th and 91 yesterday, Wednesday the 12th. The average worked out to 97.4, which is equivalent to a sunspot number of 45, which is up on the previous week's figure of 37.